Hello and welcome to the 2024 NEDTalk presentations and questions and answers or Q&A webcasts. My name is Rafael de Ameyer, Rafa, and I will facilitate today's interactive broadcast. Today we have Adam Smith. He's an applied climatologist at NOAA's NCEI, the National Centers for Environmental Information, and we will be talking about the US billion-dollar weather and climate disasters work that he works on. We'll be understanding disaster costs, hazard risks, and resilience over space and time. I want to thank the NOAA studio and my team members at the Viz Lab. And at this time, all participants are in listen-only mode. An exclusive question and answer session will follow the formal presentation. Questions can be asked by using this Q&A window below, and this presentation will be placed online. With that, I will hand it over to the NOAA studio.
Hi, my name is Adam Smith. I'm an applied climatologist at NOAA's National Centers for Environmental Information and the lead scientist for the US billion-dollar weather and climate disaster product. Today, I would like to highlight a number of our different data resources available to provide a better understanding of disaster costs over space and time, hazard risk and hazard resilience, and how the historical record has changed over time and where the hotspots are for different hazards. To do that, here is a quick outline of what I'll be talking about today. First, we'll provide some context who are our public and private sector data partners and talk about what we're measuring, but also what we're not measuring. I'd like to also highlight the historic year last year we had of these billion-dollar weather and climate disasters across much of the country and put that into historical context with other years and other extreme events. And the second half of the presentation, we'll be looking at the disaster data tools, the maps, the different interface structures we have for you to get at the data and ask different research questions. And finally, I'd like to wrap up with new and future work we're embarking on right now. So NOAA's National Centers for Environmental Information, where I work and where this product is based out of, as you can see, has a broad array of different products and services in regards to weather and climate extremes, but even other topical areas. And you can see, as this chart shows, these products go from daily to weekly, all the way out to annual and to decadal timescales. They also are local, national, or even global. And the billion-dollar disasters, as you can see in the top right, is in relation to insurance, reinsurance, and risk modeling and understanding how extremes impact our economy. So NCEI has been around since 1950, and this product kind of underscores the mission at NCEI, which is the nation's scorekeeper in terms of trends and anomalies of different weather and climate variables and extremes. So this product tries to look at the economic and societal impacts from these really impactful events because we can learn from them and better mitigate our future from what we learn about what happened during the events themselves. Over the last 44 years, as you can see at the bottom of the slide, we've analyzed 376 separate billion-dollar weather and climate disasters in today's dollars. And that does include sub-billion-dollar disasters that are now $1 billion in 2024 dollars. And the cumulative cost is more than $2.66 trillion. So certainly there are different ways you can go about doing this type of analysis. So here's a chart to kind of describe what we're doing in terms of this research. On the left, you'll see different disasters that we look at. So wildfires, tornadoes, floods, droughts and heat waves, snowstorms, winter storms, and of course hurricanes. We don't look at the geophysical events such as earthquakes or tsunamis. There is a part of NOAA that, in NCI that has those products, but this is mostly focused on weather and climate extremes. So in the middle, you'll see, well, what impacts do you want to measure? The best public and private sector data to date resides in the middle. So damage to businesses, homes, public infrastructure, private property. The purple and orange boxes are new areas of research we're working on but are not yet operational. So damage to human health and well-being, and also natural capital and environmental degradation type damages or non-market losses. So we're trying to capture the best public and private sector data that we have available, but no, it's still a conservative approach. Here's a little bit of a deeper dive into that last slide. So we have the 7 core hazard types at the top, as I mentioned before. And on the left side of this, you'll see some key public and private sector partners. So the insurance and reinsurance world, the FEMA with their presidential disaster declarations and their national flood insurance program. Also, USDA's crop insurance agency. They pay out for many different hazards. The National Interagency Wildfire Center is important, as well as U.S. Army Corps of Engineers, the Energy Information Administration, and state agencies that often do post-disaster reporting. They all provide different context that might not be available in other sources. So the X's denote the partners' intersection of their data with the hazards at the top. And from all these different partners, which are roughly about 12, we're capturing 16 different asset classes noted in the box at the bottom. So that will be total direct losses, which is insured and uninsured damage to homes, businesses, government buildings, all the contents of those structures, even time element losses like business interruption or loss of living quarters. Also damage to vehicles, to boats, to offshore energy platforms, even military bases that are damaged from hurricanes or floods. Public infrastructure is also important to capture, which sometimes the private sector and insurance folks don't really look at because it can be insured by state or federal government. So damage to roads, bridges, levees, electrical grids, which are often a public-private partnership to rebuild after the fact. Lost hydropower out west often from drought. We also can factor that in. And finally, agricultural and forestry assets such as damage to crops, livestock, commercial timber, and wildfire fighting suppression costs. So those are roughly the 16 different asset classes. But it's equally important to note what we're not measuring. In the bottom right of the slide, we talk about, as I mentioned, natural capital or environmental degradation. So coral reefs that are damaged, for instance, from a hurricane, that's not an operational input for our analysis yet because there's not quite a framework for that. Or the mental and physical health care related costs. Each state has kind of a different system, the way they track that, and so it makes it too heterogeneous currently to bring it into our analysis. And finally, the downstream ripple effects of supply chain impacts outside of a hazard region. Also, those are not in our analysis. So it's a conservative approach using the best data we have, public and private sector, in the public and private sector, but also it's still conservative because we know we can't measure everything that is damaged. So here's a chart showing 2023, which was a historic year in terms of the count of these billion-dollar disasters. There were 28 separate events that were 1 billion or more in total direct losses based on all these variables I mentioned, from the tragic wildfires in Hawaii to the Hurricane Idalia and Typhoon Moir that hit Guam, to the flooding events from the California floods early in 2023 to the Northeast and Fort Lauderdale flooding across the year. But you can see every year we also have a cluster of the tornado, hail, and high wind events, which really and easily populate above $1 billion across much of the Midwest, the South, and the Southeast. But surprisingly, the most costly event last year was actually the drought. You can see the drought kind of on the border of Texas and Louisiana. That was about a $15 billion event. And for the second year in a row from 2022 and 2023, the Mississippi River was actually very low, and it caused some commerce problems because a lot of that cargo had to be offloaded onto trucks and trains, not on river barges because of the drought. So again, last year, a historic year, but we've had quite a run really since 2017, which you'll see in terms of these billion-dollar disasters. So here's a chart showing just that. Over the last 44 years, from 1980 through 2023, and this is all inflation adjusted to present day dollars, the bars show the count of billion-dollar disasters, color-coded by type at the top, type of event, and the lines show the cost. So the black line is a 5-year running cost average, and the gray and red lines are the annual costs with uncertainty bounds around them. So the 5-year annual cost average, as you see below the chart, is $120.6 billion, which is much higher than the total loss period of about $60 billion per year. Also, over the last 7 complete years from 2017 through 2023, you see the billion-dollar disaster events alone have eclipsed $1 trillion in total direct losses. So these disaster losses are growing faster than population, faster than GDP in some parts of the country, and so we need to learn from these disasters and better enhance our environment so we don't continue to have the impacts from these extremes. Here's a chart showing each of the last 44 years and how the frequency of these events for each of the years accumulated January through December. Again, the black line would be the 44-year average at 8.5 events per year, inflation adjusted. you can see the red line was 2023, head and shoulders above all the other years. And partly that was not just inflation, but that was the addition of how much it was costing consumers to rebuild some of their assets. So it's kind of an enhanced version of inflation, but we also had many events. So you have to think of it in terms of exposure plus our vulnerability, plus for some of these extremes, climate change is amplifying them. This chart is the same setup, but instead of the frequency, it's the cost of these billion-dollar disasters, January through December, each of the last 44 years. Again, the black line would be the 44-year inflation-adjusted cost average at $60.5 billion per event, per year. And last year, even though we had the highest count of events on record, as you saw in the last slide, we were just really in the top 10 in terms of cost because we didn't have one of those catastrophic hurricanes or a really bad wildfire season that can be tens or hundreds of billions of dollars. So the cumulative cost of those 28 events in 2023 was about $93 billion, which is still a very high number, as you can see, relative to the distribution of all the other years and the average. The outlier years you see up top would be 2017 when we had Hurricanes Harvey, Irma, Maria, also the Western wildfire season, and many severe convective storm events. The blue line would be 2005, and that was, again, a hurricane-driven loss exposure with Hurricane Katrina, Wilma, and Rita, I believe, among other events. And even 2022 was another high year at $178.8 billion. So you look at a chart like this and you want to investigate what happened, where did it happen, why did it happen, and try to learn from that to increase your resilience and reduce your vulnerability. But let's look at this more spatially. So for the United States from 1980 through 2023, you can see how the U.S. South, Central, and Southeastern regions have experienced a higher cumulative cost from these billion-dollar disaster events than other parts of the country. In fact, Texas, Louisiana, and Florida really stand out in terms of the top cost for the states from these events, as you can see it to the right. Texas, $402 billion, Florida, $389 billion, and Louisiana, $304 billion. But it's important to note that these costs, of course, are relative to space, to population, to geography. And so the relative costs are actually the most acute in Louisiana because it has losses at the scale of Texas and Florida, but a population and an area and an economic size quite smaller than Texas or Florida. And unfortunately, we are seeing some of the risk management agencies and insurance companies are challenged by trying to manage insurance in places like Louisiana because of just the high frequency of events, which we'll look at. So in 2023, this is a map showing the cumulative cost of the billion-dollar disasters for each of the states. And you can see Texas in 2023 had a $13.8 billion impact. You can see Hawaii is on there, Guam, but much of the central U.S. from the severe convective storm, the tornado, hail, and high wind impacts, and of course California with the flooding. But let's actually look at it on the next slide in terms of GDP. So this slide shows the 2023 billion-dollar disaster cost for each state as a percent of that state's 2023 GDP. And you can see how at the bottom of the map, Hawaii stands out from about 5 to 7.5% of its annual GDP was proportionally wiped out from the wildfire event that happened last year, the tragic wildfire that took over 100 lives as well, and will take many years to recover from. But you can see a number of the other states, Kentucky, Iowa, Oklahoma, Arkansas, had relatively high impacts from these severe convective storm events particularly, and also Vermont, as you see from the flooding that happened in 2023. But let's step it back a few years and I'll make a point about compound disasters with cascading impacts. So that was 2023. Here's 2022. So this was the year Hurricane Ian, which was a $100 billion plus hurricane, made impact in Florida. So Florida did have a big hit from that at exceeding 7.5% of its GDP. And you see a number of other states as well. Let's go, that had 2 to 3% of impact for GDP. But let's go back one more year, 2021. So this is one year that Louisiana was really impacted from Hurricane Ida. Hurricane Ida was proportional to 15 to 20% of its GDP. and then go back one more year, and you'll see again, Louisiana was in the epicenter from these hurricane impacts and flood impacts. So in 2020, it was hurricanes Laura, Zeta, and Delta, which cumulatively wiped out about 10 to 12.5% of Louisiana's GDP. You can even see how Iowa, a one-day derecho that raked through Iowa, took out about 5% of Iowa's GDP. That was a really impactful, anomalous event. And so when you have cascading years and cascading disasters that create these damage events that are harder to recover from, you get, it creates a longer recovery period that's more costly and more burdensome, and then people leave the region. You can even see this in the research we did with the Federal Reserve. We looked at a decade's worth of total tax revenue, which is composed of about 25 different variables that varies from state to state. But you can see how Louisiana, for the 2012 through 2021 decade, had more billion-dollar disaster costs than all the different tax revenues for recovery or business tax, et cetera. And so that just shows another vulnerability and way that these disasters can really impact the bottom line at the state and regional level. So let's zoom back out for a minute and look at the cumulative costs by hazard type for the whole country. And you can look at this for any state, but we'll just look at the whole country for this presentation. So of the 376 separate billion-dollar disasters over the last 44 years, you can see that tropical cyclones, which are hurricanes, strong tropical storm systems, have the lion's share of the losses, 1.3 of the $2.6 trillion, roughly half. And they're also the highest cost per event at $22.2 billion, and unfortunately have the highest fatality count at near 7,000 direct and indirect deaths. And that doesn't surprise people because how impactful, how strong hurricanes are, and how much exposure we have and how much vulnerability we have along our coasts, which is growing year to year. But what does surprise people is the impact of drought. You can see the top line, more than $1/3 of $1 trillion from drought events. And this is largely just to the agricultural sector alone. So this is really a floor of cost and impacts. We also look at the heat component of drought when that has direct and indirect fatalities in the drought affected states. And you can see that drought has the second highest cost per event, only behind hurricane events at $11.4 billion. But finally, I'd also like to point out severe storm events. Again, tornado, hail, high wind, and derecho type events. Almost $500 billion at $455 billion. And that's growing largely from exposure, more concentrated assets and populations. But there is robust research that's looking at tornado clustering and how hail may be shifting in geography over space and time. And of course, Western wildfire seasons have been anomalously bad since 2017. 2018, 2020, and 2021 were just off the charts for Western wildfires. So a lot of trends kind of going in the wrong direction, but we can learn from these data and try to make other decisions to increase our resilience. Looking at the same data over time horizons of a decade, you can see how the 2010s decade was head and shoulders above the other decades. And again, this is driven from increased exposure, vulnerability, and climate change, of course, amplifying some of these extremes. So we have more and more vulnerable to drought in the West, which is a semi-arid climate, which can lead to longer, more intense wildfire seasons. We've seen that as well. And then in the central and particularly the eastern part of the country, a warmer atmosphere holds more water vapor and therefore can unload more of these billion-dollar flood events. And we had more billion-dollar floods since 2010 than we did in the 1980s, 1990s, and 2000s combined. So that's not just exposure and vulnerability. There's the climate change also factored into that increasing cost. And where we're building, how we're building, that's important for future risk. Here's another chart looking at kind of the climatology of these extremes just for the country. And again, you could look at any state or any region with our data on the website. But you can see really these extremes are kind of a tale of two seasons in terms of what happens traditionally. So in the springtime, March, April, May, we have a lot of flood potential in blue and a lot of severe convective storm events in green. And you can see how those taper off into the fall, where we have a climate which is more driven by drought and wildfire impacts, and of course in the brown and the orange, and hurricane impacts, tropical cyclones in yellow. And you can actually see hurricane season quite well in this chart as it kind of grows through July, August, September into October. And so looking at this in another spatial context, you can see the high frequency of events we've had in really the last decade leads to higher potential for compound disasters with cascading impacts, like Louisiana and the hurricanes, or like California, we have a drought having a longer wildfire season. Then that flips into the wet season in January, and you have the flood and debris flows. Those are all kind of chained in a tight space-time context where it increases the length of our vulnerability in certain regions for certain hazards. And you can see, again, April, May, June, a lot of that is severe convective storm event potential, where you have clustering of events. And what's kind of striking is in the 1980s, we used to go about 3 months between these billion-dollar disasters. Now we're closer to 3 weeks between these billion-dollar disasters. And, these increasing frequency, diversity, cost is particularly challenging to the more vulnerable socioeconomic populations that may not have social safety nets like insurance to help them rapidly recover. So I'd like to also switch gears here to talk about how these billion-dollar disasters look in terms of overall risk at the county scale. And this would be a compound risk. This is building on top of FEMA's National Risk Index, but looking at a compound hazard risk. So drought plus flooding plus wildfire events you see are most likely in the western part of the country, or the southwestern part of the country, Arizona, New Mexico, Southern California. And you can zoom in on this data on our website and look at how your county or your area compares to your state, or how your state compares to the country. And it gives a sense for how your cumulative exposure, vulnerability to these different extremes may be in relation to other areas around you. Here's another set of maps showing the combined exposure for tornado plus hail plus high wind events from severe thunderstorm events. And you can see, as we see geographically east of the Rockies, the risk is amplified as the synoptic systems move across the country, and you've got the warm energy and air from the Gulf of Mexico often coming up to collide with the cooler air from the west. And actually, I've got Dallas County, Texas highlighted, and you could click on that and get a lot more data, and I'll give an example. But Dallas County has the highest risk for severe convective storm in terms of its exposure, vulnerability, and just the history of that event over in that area. Also, I think this is an important map to show. People think, oh, hurricanes, I'm 50, 100 miles from the coast, no problem, I'm safe. Well, not exactly. You can see the hurricane risk actually goes quite well inland. This is as hurricanes are becoming extratropical and raining themselves out. It's happened several times in the last several decades. I actually live in Western North Carolina, where NCEI is headquartered, and we had, from a tropical storm event that came through the Gulf, almost 2 feet of rain under our house, and it damaged some possessions. And we're 450 miles from where the tropical cyclone made landfall. So you can see, the risk, particularly for rainfall more so than wind, goes well inland. Or Hurricane Ida in 2021, unfortunately, several dozen people were killed from the flooding impacts in New York, New Jersey, and Pennsylvania from Hurricane Ida that came across New Orleans. So, these risks are multifaceted in space and time, and just know your area. Let's zoom in on that last map. Here's the state of North Carolina, as I just mentioned. And you can see, of course, the closer you are to the coast, the higher your risk is, which, of course, makes sense. And in fact, just yesterday, a non-named tropical system that was just evolving dumped about 15 inches of rain where I have in the southeastern corner of the state. And a lot of flooding had happened, and the damage assessments are just happening today. I think loss of life was minimized, but damage to property is, in the recovery phase is just kicking in. So here's a view of North Carolina with a tropical cyclone risk. And again, the darker colors show higher risk. This would be heat and drought risk. This would be, and you can see how the kind of the sand hills where agriculture is prominent in eastern North Carolina have the highest cumulative drought and heat risk. Even wildfire risk. It's not like it is in the West Coast, but the Southeast does have a marginal wildfire risk that can flare up from time to time, and a lot of it is coastal in terms of the risk. And finally, flood risk. You see really North Carolina, the mountains in the west, and then the coastal plain area in the eastern part of the state have higher risk for historical flood damage and impact. And you can click on or zoom in any of these counties or census tracts. But it's also important not to just understand the exposure, vulnerability, and how climate may be enhancing some of these extremes that lead to billion-dollar disasters. It's also important to understand the human component. So we worked with the CDC and the ATSDR, the Social Vulnerability Index they have, which is about 12 different variables looking at core components of society that make society either more vulnerable or more resilient to all sorts of hazards. And so we've integrated this data as well. And I wanted to show these two maps because I think it's important to see how there's a lot of spatial correlation between some variables. For example, in the southeastern United States, you see on the right the percent of the population for each county that lives at the poverty level or below. On the left, you'll see the percentage of homes in each county that are mobile homes. And unfortunately, there's a lot of course, overlap there. And the issue is, or one issue would be, well, a mobile home is not a great place in a high wind event or a lot of these different extremes. So they need to find shelter perhaps elsewhere to protect themselves. And so these are just different components we've added on top of the physical data itself to give some spatial environmental awareness about what the risk landscape looks like. And finally, this is a study done several years ago, but it was estimating economic damage from climate change into different extremes using a high emission scenario. So it is a high scenario across the United States towards the end of the century, so 60, 70 years from now. And the reason I put this slide up is it kind of shows more of the same but worse. So in our billion-dollar disaster analysis, or in the socioeconomic information I put up in the last few slides, you see the South and the southeastern parts of the country, the counties, have been impacted at a high level in terms of cost, loss of life, the frequency of these events, and maybe socioeconomically, different parts of the region are more vulnerable than other parts of the country. But unfortunately, this also shows that the percent of county GDP, how that may be decreased in the future from the cumulative effects of climate and extremes. And so the spatial relationship of this projected outcome, I think, is important to show. So to wrap things up, what we've done in the last year would be a few of the different items I've just mentioned: the multi-hazard risk, the multi-hazard socioeconomic vulnerability risk mapping as well. We also, I didn't show this, but we have state and regional disaster reports that you can download as PDFs. They're quite thorough. And finally, what we're working on right now that we may actually have available in beta form at the end of this year would be a sub-billion-dollar event analysis down to the $100 million level, all the way back to 1980. So over the last 45 years, 1980 to present, we'll be looking at events down a whole order of magnitude in terms of cost and impact. And that may be 600 or 700 new events adding to this database. And finally, we'll be adding some other lenses as far as looking at the data through other ways of analysis to help better understand how it's changed over space and time. So my NOAA email is at the top of the slide. Please feel free to reach out to me, ask me questions, say hello. Also, some links to some of this research is on the slide here as well. And I would be happy to hear from you and take your questions. Thank you.
All right, folks, we're back. Thank you so much for your presentation, Adam. And folks, if you weren't aware, you may have realized that this presentation was pre-recorded, and it was pre-recorded in September. And as most of you probably know, there have been some events, some big disaster events occurring for us. And we wanted to give Adam a few minutes for him to talk about what's happened since this presentation that he recorded in September and now in November. Adam, please go ahead.
Hi, thank you, Rafa. So yes, indeed, since we've recorded this in mid-September, we've had the two largest disaster events in the country happen. So the first was Hurricane Helene, which came through the Florida Panhandle devastating agriculture in Georgia, up through the Carolinas, but particularly Western North Carolina and Asheville, the metro region, just devastated. In fact, that is where NCI headquarters, where I work, is. So literally, I'm speaking to you from a disaster zone that I'm describing, and it just shows you how our infrastructure um, is certainly vulnerable to many of these extremes across the country. But then 2 weeks later, of course, the west coast of Florida had the storm surge from Helene. Some of the same towns and cities and islands in the west coast of Florida also got storm surge from Hurricane Milton, another major hurricane. So those two events combined will be in excess of $100 billion, which will catapult the cumulative losses from these 24 separate billion-dollar disasters that have impacted our country so far this year, and likely into the top three of the last 45 years, inflation adjusted. And it's these really extreme events that are the ones that really have these long-term ripple effects, and what we have to learn the most from, and the recovery phase takes the longest for. But yeah, I think there's a lot of different questions that you could ask about this type of analysis, and unfortunately, our country has had its fair share of many of these weather and climate extremes over the recent years, and learning from them and making ourselves more resilient and less vulnerable, that's one of the keys here. So Rafa, I'll kick it back to you, and let's open it up for some Q&A.
Thank you, Adam. Yeah, we have questions rolling in. Our first question from Hendrik. You mentioned climate change as a factor in the rising costs of billion-dollar disasters. How do you separate the impact of climate change driven extremification from other variables like inflation, population growth, changes in land use, and increased property values in vulnerable areas?
Thank you. That's a great question. So first, this analysis has historically sought to show the economic impact over space and time, and normalizing for inflation using the CPIU index. We also look at normalizing the data, as I mentioned in a few of the slides, versus a state's population or a state's GDP. But certainly there are other lenses you could look at to normalize the data, like the total tax revenue. And so what we've done is take a pretty simple approach so far historically in our operational data, where we provide just a baseline CPI adjusted data set and then the unadjusted data set, because we know many different users or those who are pursuing different research questions, they could apply their own normalization methods or data to our data as just one input. The second piece regarding climate event attribution is another good question. This research does not take a climate or weather event attribution perspective. We don't do that analysis, but as you know, likely there are many groups around the world that do rapid assessments of climate event attribution. For example, Hurricane Helene, which, as I mentioned, devastated the west coast of Florida all the way up to the western part of North Carolina, was different factors of that, from its rapid intensification just to the moisture and the rainfall that was and flooding from that event. Some climate event attribution studies have shown that Helene was made worse because of climate change. But so we're just a part of the overall puzzle, and there are many different researchers and factors that look at different pieces of the equation.
Very good, thank you. And folks, we see questions. Is this presentation available for download? It will be made available for you to download and see at the NESDIS website. I added the link in the event information box in the bottom to the left. There's a link there to the NESDIS page, the NEDTalks. This is probably where you came in to register for this, but just so that everybody has that, we will be publishing this soon, if not today, by early next week. The next question that we have here, and folks, remember, we have that Q&A box underneath for you to add your questions. So from John, do you plan to include impact of sunny day flooding, also known as high tide flooding, in the future?
It's a very good question. We've discussed it, and you see certainly many places in the South and the Southeast, perhaps even in the Northeast, that are having these sunny day flooding impacts that, at the local scale, are very disruptive to the economy, to businesses, to transportation, just to everyday life. The cost of those events often don't materialize in much of the public or the private sector data partners that we have. historically done analysis with. So I think the answer is yes, we would like to, but we need to do a little bit more due diligence on trying to shore up what data we can use to actually um, quantify those impacts, because they're more localized and they come and they go, and so they're relatively small impacts compared to the multi-state or regional extreme events that create these billion-dollar disasters for these different hazards that we've historically analyzed. But I'll keep that in mind. Thank you.
Thank you. Yes. We have another question here from Joe. He says, thanks for the presentation. Very helpful. What is a good way to tell people how climate change is increasing the disaster costs? It is complicated, I know, but is there a short soundbite you might suggest, like maybe like an elevator speech kind of thing?
Yeah, there's a few ways you could answer it. The easiest way would you could say it's really a trifecta of problems. We have an increased exposure, where we build, how we rebuild. We have an increased vulnerability. People are they like to build in the wildland urban interface or on the coast or in river floodplains. So our exposure plus our vulnerability plus climate change amplifies a number of these extremes into billion-dollar disasters. For example, a warmer atmosphere holds more water vapor, so we have more floods in the east. But also, a warmer atmosphere is a thirstier atmosphere. It evaporates water, and it can create these flash droughts, particularly in semi-arid regions like in the west, which then feed into longer, more destructive wildfire seasons. And finally, as we know, we have more energy in the atmosphere and more energy in the ocean, so that helps intensify these hurricanes. Not only just for the wind speed, but also how much moisture they unload when they go well inland, and create floods, which we've seen much more of in recent years for a lot of these different extremes and impacts. So I think the future, we're living in the future basically. So, but we could also change what the impacts might be in the future by making more robust decisions today from what we've learned from extremes in the past.
Right. Always understanding that what you were saying, a increase in population means more
Mhm.
people are putting themselves at risk just because there's more people in the way of nature, and at
Mhm.
the same time we're observing an increase in hazards, right, from or impact of hazards because of that tilting that's happening because of climate change, right, and that combination is what seems to be driving these this increase that we're seeing. The next question from Paul. He's wondering, can you explain the inflation adjustment process more? What happens if there was an event in 1984 that did not have 1 billion in damages in 2018 dollars, but would in 2024 dollars?
Yeah, so historically, we have introduced sub-billion-dollar events that in today's dollars cross the threshold. We do that usually once a year in the spring. So, for example, you could have a tornado outbreak in 1983 that was $400 million, but in today's dollars, that's above a billion using the CPIU index. But we're actually taking it to the next level right now. We have a project going on that'll hopefully be available in the next 3 to 6 months, where we're going down an entire order of magnitude in real dollars. So instead of using the billion-dollar disasters as our only threshold for inclusion and analysis, we're going all the way down to $100 million events, and that could be a $100 million event in 1980. So technically, you know it covers the full distribution of costs using the best public and private sector data we have available. So I would say that these billion-dollar disasters currently describe about 80 to 85% of the cost distribution over the last 45 years for these hazards across the United States that we're analyzing, but they only capture, 10% or less of the frequency. So what we're doing with going down a whole order of magnitude in the threshold is we're including hundreds and hundreds of new events into the analysis, which will be available online. And that'll include the small and medium sized disasters, which many parts of the country are impacted by and are important to learn from and understand spatially in climatology context. So, and then the CPIU, we just every month we just update that into our analysis, and it dynamically adjusts.
Thank you. We have another question from Mecca, who seems to be in Asheville, North Carolina, wondering what are the top three things to do post these major hurricane events?
Well, really, it goes outside of my lane. It's really more of the emergency management response. It's, rescue and recovery, which, for days we heard helicopters around the region for Helene, or the military was here with the National Guard and FEMA. So it's response and recovery, then trying to, rebuild all of the lifelines that were lost, lost power, water, cellular infrastructure, and bringing those lines in accordance, fixing the roads and bridges so we can move around and begin the rebuilding process. But a quick anecdote: about 20 years before I moved to Asheville after graduate school to begin working at NCEI, there was a hurricane that came through, Hurricane Francis, and did a lot of flooding, washed out the water pipes. So the city and the region tried to learn from that hurricane and buried the backup water pipes even 24, 25 feet below ground, thinking, okay, we don't want this to happen again. Well, unfortunately, Hurricane Helene that just happened in late September of this year was so catastrophic, and it is the most costly disaster in North Carolina history, in modern history. Helene washed away those water pipes that were built to a 21st century standard that we thought we learned from. But it just shows you that the extremes that we're facing in different parts of the country today can shock and surprise you, even if you study and understand and try to do best practices. So, you know, um, just small steps and incremental advances in adding resilience and planning and stronger infrastructure, and also, helping people, helping especially who don't have the lifelines or the resources like insurance, which we see so much of from this flood event with Helene.
Wow. Yeah. Thank you. Thank you, Adam. And we have more questions rolling in. John is wondering, any special reason why 1 billion was chosen? Do you think your findings will be any different if the threshold were 100 million?
Great question. So the $1 billion disaster threshold was just arbitrarily defined even before my time, back when this began, and I think that it was just at that time. It took a really impactful event to create $1 billion disaster. Now, because of exposure plus vulnerability plus the increasingly, influence of climate change supercharging some of these extremes, we see a lot more of these $1 billion disasters. So, yeah, when we go down an order of magnitude down to $100 million as the inclusion threshold, yeah, I think that you'll see different areas of the country will you'll see more severe convective storm events like in the Midwest, maybe even some more events in like the Pacific Northwest, like in Idaho or Oregon, where you don't really see much in the way of certain types of severe storm events. But yeah, I think it'll add more granularity to the data and allow you to do more deeper analysis for it. And it's a lot of work, but it's worth doing. So we're excited about it.
Thank you, Adam. The next question comes from Thomas. From your research in 2017, is 2017 the tipping point in terms of billion-dollar disasters increasing in frequency and or severity?
Yeah, I think something about 2017 in particular, really to the present, it seemed like we've seen almost a state shift, like just a whole other level in terms of the extremity of a lot of these events that have taken place across all parts of the country, whether it was well, really, I mean, technically it would have maybe even started before 2017 when the US West West Coast had an exceptionally severe drought from, I believe, 2013 through about 2016, which set up the cascading wildfire seasons, which were so bad in 2017, 2018, 2020, and 2021. But you could also look at it another way. Over the last 8 years, the United States has had record Category 4, Category 5 hurricanes. Um, so we've had more in the last 8 years of Category 4, Category 5 hurricanes than we had in the prior 57 years. Looking at the data, which goes back to 1851, so there's top end events. We also had more flood events since the 2010s that we did in the 1980s, 1990s, and 2000s combined. So, as I mentioned in the presentation, whether you're talking about hurricanes, wildfires, flooding in particular, and those are extremes that do have a climate change fingerprint on them. Since 2017 to present, it's like I said, we're almost living in the future. And so, what we decide to do about adding more mitigation and resilience to our economy, to our way of life, to how we build and rebuild, to where we build, those are all very important questions.
Thank you. We have, kind of like taking into account that you're looking at what's happened versus what's going to happen, right? But there is a question from Eric wondering any future risk by peril mapping, emissions based up through 2100?
Yeah, that's kind of in the outside of the scope of our current analysis. We've had a number of people ask for that exact question, which I think is a great idea. It's just a matter of resources and kind of triaging the innovations and the new developments we're adding to the research. Um, it's also like the attribution question. It would be great to do attribution, which is a whole other type of research, but it's currently beyond the scope, but it's on our to-do list, and it's something that we would love to make happen.
Very complex too. Here at the VisLab only, we taking the SSP, the
Mhm.
societal pathways of different emissions to the future, just looking at like how temperatures change or sea level rise, all the factors that we're looking at, that's already extremely complex. Adding value of disasters over that, yeah, I can see how you're still not there, but hopefully you'll get there. A question from John here. Do you plan to include the impact of weather events on closed schools slash learning?
So that would be, if I understand the question correctly, that's kind of a business interruption type question. I don't think that's part of the asset class collection of the data we have access to. It's an important question, but I don't think we currently don't include that, I don't think, and I'm not sure how to exactly do that, but it kind of goes into the broader scope of how do these extremes just massively disrupt one's life. I'm speaking to you 6.5 weeks since Helene made landfall here in Western North Carolina in Asheville. We still can't drink the water that comes out of our pipes right now because it destroyed the water filtration system. So, there are a lot of time element losses, which is a fancy way of saying how do the impacts how can you monetize impacts of things that are not often tangible or as tangible as you'd like them to be. So we're always thinking about that, but also we have kind of a high threshold of inclusion. If we ever to make if we were to make a change to our analysis, it would have to go back preferably to 1980 for the full country, so we could homogeneously incorporate that through all the different analyses that we've done over the period of record.
Thank you. We have another question here, which admittedly they even say it might be out of your scope, but let's see what you think. It's from Lorenzo. He says, really interesting talk. I imagine this might not be within the scope of your project, but curious as to what level potential future improvements and resiliency, like through building codes or adaptive behaviors, are included in long-term future projections of billion-dollar events damage and frequency.
Thank you for the question. Yeah, that's beyond our scope, but I can provide a good anecdote. So in 1992, when Hurricane Andrew came through southern Florida, it was a devastating, impactful event. One of the early hurricanes in the modern record that was just really shocked a region. And what they did was they said, no more. Let's increase our building codes. So that's why Florida to this day has, particularly since the year 2000, has really robust building codes, and they should because they're a peninsula that's very prone to hurricane impacts, as we've seen. But so what that means is, like with Hurricane Ian a few years ago, or Hurricane Milton that just hit the west coast of Florida, for at least the wind component, you see a lot less damage to more modern construction homes, businesses. But if they're pre 2000, the impacts are quite severe, particularly if they were older building stock. The water damage, that's more of a function of how high the base floor, the base elevation is built above where the storm surge would come through. So that's a separate problem. But so yeah, Florida's done a good job, but unfortunately, much of the country hasn't chosen to really institute a robust building code. Granted, yes, it does increase the cost of building, probably up to only about 10% though. So long term, if you run the math and run models on it, it would pay for itself sooner than later for many regions, for many hazards. But that's, I'm not an engineer, that's out of my scope. But at least we see Florida, what they've done, and there are some good benefit cost analysis studies that show that it was a good investment.
How interesting. Thank you. Another question, David, this time, and he's identifying himself as David from Covering Climate Now, perhaps the media. Thanks for this presentation. He wonders, in the presentation, in the recorded presentation, you said that drought was the highest cost event this year. Has Helene since taken the number one spot, or is there more analysis needed?
Yeah, as a quick correction, so the presentation I was speaking to, that was an aggregate of the disasters for 2023 last year because I wanted to speak to the full year. But so in 2023, the $15 billion drought was the most costly. But this year, Helene will likely be the most costly. Helene, followed by Milton. Those are tens of billions of dollars each. I know the state of North Carolina has actually come out with an early assessment showing a $53 billion price tag just for North Carolina for Helene, and that um, we're doing our own analysis as well. But that just shows you the scope and the magnitude of the devastation. And I've driven through it. I've seen it. It's incredible. And so hopefully this year we can wind down and no more disasters because it's been another active year.
That's right. Yeah, and for to be clear with everybody, Adam's presentation, because it was before these events, right? He was more focusing on the on prior years actually. So that slide that he showed there as we went into the Q&A, that was talking about 2024.
Right.
Another question here from Matthew. Hi, Adam. You mentioned insurance companies use this data. Do you know if there have been successful adaptation programs that have been implemented using this data? For example, cities investing in infrastructure or limiting development in certain areas.
Yeah, I think that actually, I think that insurance and the reinsurance companies, they look at this as a data point, but they have their own internal data and their own models as well. But to answer the other piece of your question, I'm not immediately aware of others using this analysis and making a decision that had a positive outcome because I just don't really track it that closely. So they may be out there, but we view this as one tool in the toolbox, or it's one part of this larger growing ecosystem in the public and the private sector that's doing a lot of really important and interesting analysis. And it's a collective uh, you know analysis and pushing the boundary of innovation that we can collectively better understand what our risks are, what our vulnerabilities are, and of course how climate change is supercharging many of these extremes into billion-dollar disasters, because those are all trends that no one wants to happen, but unfortunately they are happening. So what can we do to slow that trend down? And there's a lot of different avenues for that.
Thank you, Adam. The next question is coming from Duncan. He says, I may have missed this in the beginning when you were talking about data sources, but are you including slash estimating degradation of natural resources? And he includes, the NOAA's Chief Economy Office has a natural capital accounting assessments of losses to natural resources like estuaries, timber, etc.
We partially do that, but that's something else we also want to increase the scope on. So for things like commercial forestry, which is of course a commercial asset, or the impacts that drought can have on like the Mississippi River, that's a transportation corridor, it's a wildlife corridor, or lack of hydropower, which is a utility, but it's also part of the natural system as far as keeping the water flow robust. for a lot of end users. So we do it fractionally, but as you may know, a lot of these quasi non-market losses are too heterogeneous. They don't have a lot of robustness over space and time and are consistently available. So because of that, we can only include those that are robust and have a lot of consistency over space and time. So it's actually I'm on a White House OSTP team, and we published a paper and wrote a report, have done presentations on how can we develop new data series and frameworks to expand the scope of these non-market losses. And so that is, again, it's another active area of research.
Thank you. Questions are still coming in. We only have 5 minutes left, so we're going to try to accelerate this. So the next question from Michael, he's wondering if you have considered including damages from harmful algae bloom events, like red tides.
No, I know other parts of NOAA, like NOAA fisheries, they look at this much deeper at the kind of the wet side of extremes and impacts. So there are certainly parts of NOAA that do that. That's again, I think, outside the scope of just the strict weather and climate extremes that we've analyzed historically. But these are all great questions you're asking, and really make me want to to do even more. But it's just a matter of what's practical and what's the order of innovation. But thank you for the question.
That's awesome. A question from Matthew. And we do have an international audience. Do you know of other countries that have a similar program? Has there been any interest in collaboration with Canada or Mexico? I know NCI collaborates with them with things like the drought, right? Like North American drought. What
Mhm.
about billion-dollar disasters?
Yeah, I've been on a number of interagency and international teams, like with the World Meteorological Organization, and actually just gave a briefing last month to Africa. And a lot of African countries were asking, "Hey, we'd love to have a system of data like this for our countries." And so that's kind of an open dialogue. But fundamentally, you have to have the public and likely public and private sector data sources available for a good bit of time consistently to even embark on this type of analysis. So if you're a place in the world that's data sparse, the first thing to do is design a good data system or leverage others that could help you. And so yeah, we've had some discussions with Canada. They've done some analysis that's similar to ours, and I knew some folks in Mexico as well. But honestly, the United States it's just been it's such a continuous stream of disasters that have been so impactful year after year after year. It's all we can do to keep up with them in the United States right at the moment.
There's a question here from Joe. He's saying, just wondering how economists might factor in the recovery costs as recovery boom. In other words, there is an economic boom with the rebuilding expenses during the recovery work.
Yeah, that's a separate question. A lot of people could run CGE models or input output models to look at how there's a dip in GDP or lack of spending and impacts and damage before, but then the building phase and the quarter after has a little bit of a bump of robustness above the baseline. And so for some disasters, if a region is relatively robust and bounces back rapidly, those they don't quite cancel out, but yeah, there is something to that. That's a separate type of analysis, and so we don't explicitly incorporate that frame of logic into our analysis. But it's a good question.
Thank you. Quick question: Why is extreme heat not a category by itself? Question from Paul.
It's a good question. So yeah, historically we've always had extreme heat with droughts, but some droughts are just dry droughts and not they don't have a heat component. We've thought about partitioning the drought from the heat wave events, and I think it's a great idea. Really, we need to get more robust information for a variety of sectors and not have it so focused only on human health as far as mortality and the impacts to agriculture and forestry and hydropower. We need to expand the scope of what heat really does to the human environment and the economy. And once we've done that, then we could certainly make it its own category.
Thank you. And we're gonna, folks. Thank you for sending your questions. Thank you so much for all the nice words that you have. And great, Adam, I don't know if you saw it. Great presentation. Everybody really loved it. I have a good last question for you here from one of our viewers. Thank you for the great talk. I am wondering, what's the most urgent topic you think should be studied for urban resilience upon climate change and disasters?
So that's a tough question. Um, I mean, enhanced building codes, but also with that enhanced infrastructure in general, whether it's how you generate your power, electricity generation, solar is modular versus something that's more centralized. How we rebuild, where we rebuild post disaster, how you manage your water infrastructure, your cellular, your internet infrastructure, because all of those came down from Hurricane Helene, and we're 400 miles from the ocean where Helene made landfall. So, and of course, with an urban setting, you have more concentrated population, which could be a boon or a bust depending on how resilient your population is and your infrastructure. So, great question. It's a loaded answer.
Yeah, complex. I'm originally from Spain, where there was this Dana, an atmospheric event that brought a lot of water over Valencia, and one of the biggest problems that we have there is that folks will rebuild in areas that maybe have like a 50-year flooding kind of. So yeah, it hasn't flooded in 50 years. It should be okay, right? And they build there, and here comes the flood, which is coming with an increased periodicity now, right? With less time. So yeah,
Yep.
excellent, folks. Thanks everybody for joining us. Adam, thank you so much. This was an incredible presentation, folks. We'll be seeing you soon. Keep go to that website, the NEDTalks website. You'll see there what else is coming up, and we hope to see everybody soon.